For the longest time, we found comfort in geometry. We looked at the chaos of the universe and tried to draw it with sharp lines. This is the Jupiter I taught my students for 20 years. A gas giant built like a cherry, atmosphere on the outside, liquid metal in the middle, and deep down, hidden under 40 million atmospheres of pressure, a seed, a solid, rocky core. We assumed that if you could somehow survive the crush of gravity, you could, in theory, stand on something. We believed the king of planets had a heart of stone. We were wrong. July 2016. NASA's Juno probe enters orbit. Juno didn't go to Jupiter just to take pictures of the clouds. It went to perform a CAT scan. We can't see inside a planet with light, but we can feel it with gravity. As Juno swings past the planet, the density of the interior pulls on the spacecraft. If there is a dense mountain of rock deep below, Juno speeds up. If there is a void, it slows down. We waited for the data to confirm the cherry pit. We expected a sharp spike in the gravity field, a signature of concentrated mass in the center. Instead, the data came back blurry. The gravity signal wasn't concentrated in the center. It was smeared out. It extended nearly halfway to the surface. We call it a dilute core, but that is a polite scientific term. In reality, it is a fuzzy core. Imagine the core isn't a pit. Imagine it is an aspirant dissolving in water. The heavy elements, the iron, the silicon, the ice, they aren't sitting in a pile. They are dissolved into the liquid metallic hydrogen. There is no floor on Jupiter. There is no surface. If you fell in, you wouldn't hit rock. You would just sink through a soup that gets thicker and hotter and stranger until you became part of the solution. This discovery forces us to ask a terrifying question. How do you dissolve a planet's heart? Rock doesn't just dissolve into gas on its own. You need energy, unfathomable energy. You need to stir the pot. The leading theory is violence, a giant impact. We suspect that shortly after Jupiter formed, it wasn't alone. It had a sibling, a massive planetary embryo, 10 times the mass of Earth. It didn't just graze Jupiter, it hit it head-on. The impactor punched through the atmosphere and smashed straight into the primordial core. The energy was so high, it vaporized the core instantly. It churned the rock and the gas together into a chaotic slurry. And because Jupiter is so massive, that slurry never settled back down. It has been swirling in that broken, dissolved state for 4.5 billion years. However, science is rarely satisfied with one answer. New simulations from 2024 and 2025 suggest another path. Perhaps it wasn't a crash. Perhaps it was hunger. We used to think planets formed in steps, build a rock, then suck in gas. But if Jupiter formed fast enough, it might have devoured rock and gas simultaneously. The pressure and heat of this rapid feeding could have prevented a solid core from ever forming in the first place. It may not be a broken planet. It may simply be a planet that never finished baking. Why does this matter? Who cares if the center is rock or slush? Because Jupiter is our template. It is the yardstick by which we measure every gas giant in the galaxy. If our model of Jupiter was wrong, then our model of Saturn and the thousands of exoplanets orbiting distant stars might all be wrong. We thought we knew the king, but the king has secrets. Juno taught us that even the largest things in our solar system are fuzzy. There is no solid ground in the cosmos. There is only matter, energy, and the gravity that binds them. And we are just beginning to see through the clouds.